Good evening, everyone. So for those who just joined us, thanks for coming to this public lecture of the Chronobiology Society of Canada. And this is a session that's co-hosted with the Réseau Sommeil and the Canadian Sleep Research Consortium. So we're delighted for the end of this public lecture to welcome Professor Roelof Groot from the University of Groningen in the Netherlands, who will talk to us about daylight savings time, a very timely topic for us here in Quebec. Thank you.
So, thank you very much. Thank you for the invitation. It's always an honor to be here. I think I was at the first CSC meeting also, which I enjoyed at the time. And it's great to be back. So we'll be talking, I like this introductory slide. It shows you that humans have an internal clock in the brain, and that internal clock, if you visited the last speakers, of course, is regulating our sleep-wake cycle. It's the important feature of this talk. But the internal clock also watches the sun. And here's the little Earth, and the Earth is rotating around its axis, creating a 24-hour light-dark cycle. And that light-dark cycle is the main synchronizer for our internal clock in our brain. So let's talk a little bit about that. But if you want to remember one thing from this talk, it's great if you want to remember more things. But if you want to remember one thing, it's this one, all right? So why do we have these clocks? Well, 4.5 billion years ago, the Earth came into existence, and already a mere, less than 1 billion years, so 3.8 billion years ago, first life emerged. And that first life, we think of them as bacteria, it's a bit shifted, cyanobacteria, and they have made these, what we call stromatolites. Now, these cyanobacteria are photosynthetic bacteria. They need the sunlight for food. And so they have developed already internal clocks that we have studied quite well. And we know that therefore we know that internal clocks to time the physiology of the organism to the 24-hour day have existed in the very early life forms. And throughout evolution, they have been perpetuated over the generations and the multiple species. Look at this tree of life. My God, it's amazing. And perpetuated until early humans that, well, we have only existed for 300 million years. What is it? Yeah. For 300,000 years, modern humans. So this rotation of the Earth around its axis creates this 24-hour rhythm of sunlight with a light part of the Earth and a dark part of the Earth, but also the tilt of the axis creates seasons, and it's also for the seasonal, to keep up with the seasons, the internal 24-hour clock is required. So you can imagine the fact that most life forms reproduce in spring is also depending on these internal clocks. So it's pretty important for evolution. Now, how does this work in humans? We have in the hypothalamus a tiny nucleus called the suprachiasmatic nucleus. And here we have the suprachiasmatic nucleus of a mouse that has been equipped with a gene that can emit light. And we see these wonderful rhythms. You say it's much faster. Yes, that's true, because 1 second is, 24 hours of the day is compressed into 1 second in this little movie. So a wonderful oscillation, and it's noting the oscillation of a clock gene, in this case the PER gene. You can forget about all of that, but we do have genes that regulate these oscillations, and we know a lot about them, thanks to many colleagues here in the audience, actually. Now, it is one of these clock genes, PER, that is induced, the gene is switched on by light, and light is entering, sunlight especially is entering through our eyes and the specialized photoreceptors in the retina of our eyes that does their job. So that's how the synchronization to the light-dark cycle works. That's the sun-light-dark. Throughout evolution, it was the light-dark cycle of sunlight. And so until maybe 150 years ago, people were actually using that information and they wanted to organize the social life. And they organized their social life through a sundial. And it just happens to be a coincidence that the most beautiful sundial in the world, I'm challenging you, the most beautiful sundial in the world is in my city of Groningen, in the Princeton town. And it exists, it was built in 1731. And it has, I think, what I always show this to my students, I think, before I start my classes, because the Latin text here describes a wonderful theme. Past time is nothing, future time is uncertain, current time is unstable. Take care that you do not waste your time, that is. So that could be the second thing you could remember from this talk. All right. Now, of course, in the past, people have been using very ancient structures to function as a sundial. Of course, here we have famous Stonehenge, and later in Roman times, they made these Roman sundials. This is just a pillar. The pillar casts a shadow, and you can read time of day on the ground surface, on the tiles on the ground surface. Basically reflecting the light-dark cycle by the sun, basically reflecting the rotation of the Earth as evolution has shaped us to. It's only later, and this is one of the earliest representations of a mechanical clock, and this is really where problems start. So this is a Chinese Suzhong's water tower clock, so the water provides the energy for the mechanics to turn. This is already thousands years before Christ. So why are problems emerging with mechanical clocks? Well, this is it's the mechanical clocks that allow us to change time in society. It's the mechanical clocks that form the basis for something we call society time. All right? And therefore, it has become also a political force, as you will see in the rest of my talk. Politicians are using the mechanical clocks or clocks on the wall or digital clocks to manipulate wake-up times in society. Really, that's what it's about. I'm a little bit strict with my definitions here, but I think that's what it's about. Now, you can imagine if you would present that to somebody from the Stone Age time, they would be worried to have to. So this is like a little cartoon from the Netherlands that I love. I cannot translate it literally. It would be offensive, I think, to this audience. But basically what they're saying is, every 6 months we have to replace those stones by 1 meter. It's just horrible, this daylight savings time. Yeah, I won't translate the names. I won't translate this sentence either. Anyway, for those who know a little bit Dutch. So let's talk about these themes. Here are the 4 themes. I'll explain something more about the biological clock, or better, the circadian system. Circadian meaning circa dies, so it's about a day or 24-hour internal clock. Then I'll talk something about the circadian syndrome. We need to understand circadian syndrome and stress, or circadian misalignment syndrome, as we call it. And then I'll talk about time zones and health, and I'll talk finally about daylight savings time and health. It's very important to understand time zones first in order to understand daylight savings time, because daylight savings time is nothing else than adopting the time from the wrong time zone. Think about that, yeah? All right, so biological clock. Here we have this suprachiasmatic nucleus again that you saw, and what it does to the body, it is synchronizing all these rhythms in these tissues. Every cell in your body has the capacity of generating a circadian rhythm, because every cell has those clock genes. Now the SCN, the suprachiasmatic nucleus, is the master clock, and it has the beautiful task to synchronize all these rhythms, and it can do so through melatonin, you heard about that, adrenal glands, glucocorticoids, we'll talk about this. The adrenal gland produces glucocorticoids. Anybody knows glucocorticoids, stress hormones, cortisol, yeah, kind of stuff. But also body temperature turns out to be very important. And so if we sleep, of course, the behavior is also synchronized by this clock. So if we sleep, and we heard in the previous talks all about the importance of sleep, if we sleep at a specific time of the biological clock, a preferred time of the biological clock. And this is not trivial because it means we don't eat, so the liver can do other tasks, but also things like immune system can be synchronized to our sleep phase. If this organization is compromised, it is an unhealthy situation. So let's talk about this unhealthy situation. So what are the functions of the circadian system? Well, we think if things are in place, there's an external function. I have to sort of... Okay, external function, which really is about the synchronization of behavior and physiology with the environment. And think about the environment of light, temperature, and humidity. And in nature, photosynthesis is important for the synchronization, but also predation, thermal regulation, and circadian clocks can also measure day length. Now, there's also this internal function, synchronization of peripheral tissues and function with each other and with behavior, and as I indicated in the previous slide. So digestion needs to be synchronized with your eating behavior and with the liver metabolism, physiology and behavior, sleep, immune function, as I said, tissues and hormones. A nice example that I always tell my students is, for instance, in the hypothalamus, this hormone is produced to trigger a luteinizing hormone peak in the pituitary, and that triggers ovulation. But each of these three steps is dependent on circadian clocks, and if they're not synchronized, you won't get ovulation. It's a very important example why fitness is immediately negatively affected if synchronization in the body is not right. And then we know now that in these various tissues, general gene expression is synchronized because these molecular clocks, they do regulate gene expression in your various tissues. Here's a great experiment that Frank Scheer did at Harvard Medical School with his team, where he let people sleep at different phases of the circadian clock by asking them to sleep with a 28-hour rhythm. Now, your circadian clock can't keep up with 28-hour rhythms, so they're forced to sleep at some point at the wrong phase of the clock. Now, the correct phase when they start the experiment is here in green, that's the aligned situation, and the wrong phase is here in red, that's the misaligned situation. You see it has effect on hormones, but here is an important notice. Glucose levels are high. They peak after each meal in both situations, but they're much higher if they are misaligned. If you have to eat while your circadian clock tells you to sleep, but like in shift work conditions, you're eating, your glucose levels go up. Now your body tries to regulate it down because insulin is meant to bring down those glucose levels. And you see insulin is also higher, but apparently it's not able to bring down those glucose levels. So this is a pre-diabetic state. It's an unhealthy state. If this reoccurs, this is only one night, but if it reoccurs again and again in a chronic situation, you'll have cardiovascular problems. Here is the cortisol rhythm, and you see that cortisol is just continuing. Even if you sleep at the right phase, we see that cortisol is dipping in sleep onset, going up in the night, and it's sort of peaking if you wake up again. But if you sleep at the wrong phase, cortisol doesn't care. It just continues. Cortisol is one of these synchronizers. It's called the stress hormone. Well, it's not a stress hormone, even in normal daily routines. It's nicely cycling. And it's important for the synchronization of your tissues. And we know this because if we manipulate cortisol in an animal study here, together with my good colleague in Groningen, Peter Meerlo, and the PhD students, we give these mice stress at a certain point, and what we see, it's a complicated slide, but what we see is that the liver, but also the lung, and here the kidney, is shifting its rhythm. They have receptors in these tissues that respond to cortisol, and they change this clock gene purr, and they will shift the rhythm. So stress is causing internal misalignment, as if you're in a shift work situation. If I ask an audience of doctors, there must be doctors in here, why is stress making you unhealthy? I get vague answers. And what we propose here is that stress is an unhealthy situation because it is causing circadian misalignment. So chronic stress causing circadian misalignment, which is comparable to shift work. And how do we know it's comparable to shift work? Well, if you look at the health problems that occur here in the right columns, the health problems that occur in shift work, and maybe you can't read everything, but these are sleep-related, cognition-related, gastrointestinal problems, cardiovascular, metabolic, renal function, respiratory function, cancer, and headache and muscle pain. They all occur, they're all references where it's been reported in shift work. But for each of these complaints, you can make a similar list where it is occurring because of chronic stress. And so this is a really good evidence that circadian misalignment can cause all of these complaints, which is a long, life-threatening list, I would say, if it's on a chronic situation. All right. Circadian syndrome and stress. Where are we time-wise? Oh, okay. Okay. Oh, okay. Oh, okay. It's good. I was worried. All right. Time zones and health. So let's talk about time zones now. As I said, you need to understand time zones in order to understand why daylight savings time is maybe not so healthy. I need more slides for this. The logic of this is that time zones, in my view, can be seen as a worldwide chronobiology experiment. Aren't we lucky as chronobiologists that we have, politicians that install time zones so we can study the effect on the biological clock? It's very rare, I think. But then, moreover, daylight savings time, I shorten it here for DST, daylight savings time can also be seen as a worldwide experiment. It's not a very clean experiment, not as clean as time zones, because daylight savings time most often is installed in summer, but there are cases where it's installed year-round, and we can compare that before and after it was installed, you'll see. So daylight savings time can be seen as a worldwide experiment in the sense that you manipulate one thing and you look at the causal effect it has on health in this case. And the third one is daylight savings time is adopting the time of the time zone east of your current location. All right, you're with me? Yeah? You're advancing your clock, you say you add an hour in springtime, which is actually the time zone as people would have east. Now, it's a little bit hard to imagine if you're here on the east coast of Canada, because there's no country east of you, but in Montreal. But in fact, this is what it is if you think about it. Okay. Now, where does the idea of time zones come from? So I like to introduce a little bit of history. I think I have to move to my other microphone now. Yeah, it works. Ah, brilliant. They don't like it, but I asked them, and I'm permitted to do this because I want to read from my slides. So if it's okay. So here is a very interesting guy who invented time zones. It's Giuseppe Barilli or Quirico Villopanti, and he was an interesting person. He was a mathematician, University of Bologna, but he also was a politician, and he was part of a team that was kind of interesting that kicked out the Pope of Rome. Huh? So they wanted to start a republic. They wanted to make of Central Italy a republic. And the Pope saw it coming and he fled to Sicily, I believe. And so for a short period of time, there was something called the Roman Republic, 1849, 1861. After that, it became a kingdom again. So they kicked out the Republicans and kingdom was installed. Then it went back, as you know. But he published in 1858 a book called Miranda. Now I won't advise you to read this book. I found it online and I read something. It's a lot of religious crap, but Excusez-moi. But there is this paragraph, 1275. Actually, it starts here. You shall reckon days both by universal and local time. What it means that he sets a time zone, a universal time. It begins at the true midnight on the upper meridian of the Capitol Hill. This is, for the Americans, this is not Washington. This is Rome. Don't imagine and don't think of anything. It's Rome. Okay. Then 1275, he says, divide the surface of the globe by meridians into 24 longitudinal regions or fuses differing from each other by 1 hour. Beautiful. And then, of course, he says you need to know the time in Capitol Hill, and then you can calculate the time where you are if you know your time zone. And just for people here in Europe, he makes some examples. He says, we shall, for instance, be certain that when it is 14 minutes past 3 local time at London, it is the same at Dublin, Edinburgh, Paris. Oh, now it's becoming Paris, Brussels, Amsterdam, and Madrid, and Lisbon. This is very interesting. Keep this in mind. We'll look at the situation later on. Remember this for the rest of the talk. All right? And at Timbuktu, in the island of St. Helens, I don't know why he mentioned those, but it's just the whole time zone. So it extends in Africa. In short, all over the extended second longitudinal region. And he takes on other examples. So this was his idea. Now, how did it develop? It was ignored for a long time. But in Europe, in Britain, 1840, the Great Western Railway in England, the first use of standard time, Greenwich Mean Time. So it's not yet time zones, but they needed for navigation, the Admiralty needed to know time. Because without knowing time in London, in your main port, you wouldn't know your longitude. It was very important to keep time at sea. So that's why it started there. And the railways adopted it. Now the Royal Observatory in Greenwich sends out the first standard time signal by telegraph. Modern communication techniques. So it was important to send out the time signal all over the world. And then in 1963, Coordinate Universal Time was replaced GMT all over the world. I must admit I still use GMT, many of us do, but actually it should be replaced by UTC. In USA, the 19th century railroads were a mess. I mean, in the sense that they were owned by various companies, not in the UK, but in the USA it was. Now, those companies have the railroads, but they had to sort of rent it out to other companies to pass on the tracks. Now, the companies had their headquarters in certain cities, and the companies worked, each railroad company used its own time based on the headquarters' local time. But they were using each other's tracks. Many accidents happened. Terrible situation. So they had a strong need for standardized time zones, especially in the USA. And it was in 1883 what they called the Day of the Two Noons, where each railroad clock was set to the GMT linked to USA time zones. Okay, so fast transportation required time zones. So this is what the world time zone map looks like. Is this interesting? Well, if you look carefully, I think it's very interesting. First of all, Amsterdam, Paris, Madrid, we are not anymore in the same time zone as London. Remember the text? We were shifted. And we were adopting a time zone east of us, the German time zone. If you look all over the globe, this happens more often. If you follow here the time zone, you see in the States it bulges out, Mexico, but also here in Canada. And the bulge is to the left, which means that those regions have adopted the time zone east of them. All right? Which means that the people here, where am I pointing at? Saskatchewan? Saskatchewan. They have to wake up 1 hour earlier than they should, according to the time zone. And I feel with them connection because I, here in the Netherlands, have to wake up 1 hour earlier than I should. We have adopted a time zone east of us, and it happens all over the globe. If you plot this, and here somebody plotted the hours of solar noon after 12 o'clock. So solar noon, I mean, it should be 12 o'clock on your watch at the moment that the sun has the highest position in the heavens. If it doesn't, it's red. So it means that you basically, if you think about it, it means that you have to wake up 1 hour earlier if it's sort of pale red, or 2 hours earlier than you should if it's dark red. Now look at this map. The blue is the opposite. You hardly see any blue. The map is almost completely red, which means that countries had decided by the installment of time zones already decided to rather adopt a time belonging to the Eastern time zone, east of them, making the people, forcing the people to wake up an hour earlier than they should, or maybe even 2 hours earlier than they should. Look at Argentina here. What? Look at China. This whole of China covers 4 time zones, but the whole of China has to live by the time of Beijing. Now, I've got many students from China and asking them, and they're telling me, well, we don't really. If we're in the east, we are compensating for this. So the school times in the east of China are later. Sorry, if in the east, the school times in the west of China are starting later than in the east. But that compensation is not full. But my point here of this slide is it's a political decision to force your population to wake up earlier than they should. All right. Why is that important? Well, here we have a data set by Michael Thurman focusing on the time of year in winter solstice. And you see here, this is the time, the sunrise, the axis is the other way around, mind you. So this is sunrise time from right to left. And the sunrise time in the red, in the west of the time zone, of course, is later than in the east. Sunrise is east, right? Now, if you plot data from the psychiatry ward, and here we have the relative severity of depression on the y-axis, it increases by latitude. If you move north, you coming from the blue to the red zones. If you move north, the severity of depression increases. But also, if you move from east towards the west, your severity of depression increases. Remember the list I showed you with stress and shift work? If you mess with the circadian clock, depression is one of the features that you'll notice. All right? Now let's look at the situation in Europe that I know best. Here we have a situation of the time zones before 1940. That's pretty good. It's almost as suggested by our Italian friend. Amsterdam, Paris, Madrid, we're all in the same time zone as London. Okay, Amsterdam time, before that it was Amsterdam time, but at some point Amsterdam and the Netherlands decided to stay in the same time zone as London. As did Germany, Italy, Poland, they're also nicely aligned in the time zone. By coincidence, there's a time zone border that almost is on the borders of Germany, the Netherlands, Belgium, France, Switzerland, Italy. However, after 1940, we found ourselves in Europe in this time zone configuration. You may imagine what has happened. After the occupation by the Nazis, they installed what I like to call Nazi time here in the Netherlands and Belgium, France and Spain. And thank you, Canadians, very much for taking part in liberating my country. But you forgot to get rid of the time zone issue. That's our responsibility. But it's still, you know, it's still an issue. So time zones and war, they belong to each other. And time zones and war belong to each other, but so does daylight savings time and war, as I will teach you. Now, how do we study these things? And this is really an honor to present many data from Till Runeberg, because Till Runeberg is a good colleague of us, has done so much in our understanding of human rhythms in society. And his idea was, let's do a worldwide assessment of the human circadian clock. And so what he needed is a very simple questionnaire, and you must have seen this. For those of you that don't know this, please do this in your mind. The only thing that's really important in this questionnaire is, when is your sleep onset and when is your sleep offset? And with those two values, you can calculate your mid-sleep. Now, there is a slight edge, because your mid-sleep, especially your wake-up time, your sleep offset, will be affected by whether you're using an alarm clock, whether you go to class, or whether you have to go to work, okay? So those societal tasks will affect your mid-sleep, especially by advancing your sleep offset, as we will see. So you have to calculate your mid-sleep on work days, but you can also calculate your mid-sleep on free days. So from these questionnaires, Till collected for every person 2 important values: mid-sleep on work days and mid-sleep on free days. And this is a fantastic book. He published more books that are translated in English. If you want, you should look them up. But his data set that he collected over hundreds of thousands of people, and this is now a early version, population in Germany mainly, you find a huge distribution of that mid-sleep. And the late types are here in red, and the early types are in the blue colors. So you can, if you do your calculation for yourself, you can calculate where you are. Okay, I've done this. People that know me, they know that I'm sort of in the danger zone here. But the average is sort of here in the green. 4 would be great. Now, there's large variation, and we think this relates to the circadian clock of humans. In general, you can say the later types are around 20 years of age. Men are later than women, very interesting, so we think it's a hormonal issue. The development also tells us that maybe there's a hormonal issue because it peaks at 20 when development has stopped. And reproductive hormones are peaking. And then we have late chronotypes are often sleep deprived, because the late chronotypes with the slow circadian clock, they have to wake up with an alarm clock on work days, and late chronotypes have reduced performance, mental as well as physical. Here is the curve over age. You see it peaks nicely. Young children are early chronotypes. At the end of adolescence, they're late chronotypes. Men peak a bit later than women because they develop, of course, slower, as we know. And then, no comments, okay. And then once here when men and women look hormonally maybe a bit more similar, we see that the chronotypes are also more similar around menopause. The nice thing, of course, in the graph is, it's for school kids, I always tell them, well, who is defining your school times? And those are the gray people here, 50 plus, the directors, right? The directors of companies define work times, directors of schools define school times, but look at the kids that they have to teach. They are an hour later. So teachers should realize, do they like to work and teach on the time that they feel comfortable? Or do they like to teach at a time when the students have the best mental performance? So maybe school time should be adjusted for this. Now, Till Runeberg did a wonderful correlation. Now I think I'm running late, huh? Yeah. And here we see, in a time zone, we see this chronotype. And you see that the sleep times in east of Germany, they are much earlier than here in the West, and the Netherlands, that was in the same time zone, we are very late chronotypes. And this correlation to these points with latitude is not the correlation line, it is actually the sunrise time, the difference in sunrise time. Wow. So really, the human circadian clock, especially in rural areas and small cities is entrained to sunlight. That's an important point. Now, do those countries in the West compensate? Yeah, they have slightly earlier local times, so this is work times, but the compensation is not complete, so there still remains a problem. Now, if you compare West versus East, there we find an estimated increase of depression with 10%, smoking 35%, alcohol consumption 10%, obesity 1 BMI. This is I emphasize an estimated difference because there are many cultural differences, of course. We also see here the study that we've done in high school kids. We see that the late chronotype have lower school performance. Their grades are lower. Unless they're tested later in the day, then it's equal with the early chronotypes. But basically, early chronotypes do much better in the morning than the late chronotypes, as you would predict, because they are under sleep deprivation, the poor kids. Here we see the correlation with chronotype and depressed mood. This is also a study by Till Ronneberg's group. We see, of course, more caffeine drinks, higher percentage of smokers. I think this is this number is so high that I think it is the probability of the amount of cigarettes smoked per smoker. And here is the alcohol consumers. So all related probably with also a more depressed mood. Now, here we have another concept that Till Ronneberg introduced, and this is called social jet lag. If you are an early type, then you have very little social jet lag, meaning that the difference between the weekend days in bright yellow and the work days in dark yellow is not so different. But if you are a late type, you want to sleep in the weekends, but you have to wake up early during the weekdays. And here you see, here is sleep plotted in blue. This is what causes your sleep deprivation. So, and that amount of social jet lag correlates with more sleep deprivation. By the way, this picture is from a book that will come out, Hutt and Swartz. I wrote with Bill Swartz. It'll come out soon. So if you're interested in these plots, it will be free to use probably this summer. Here are more correlations. Here we have overweight correlates now with social jet lag, and it's the late chronotypes that have more social jet lag. And if you are a little bit overweight, you can run into obese if you sleep late and if you have sleep shortage. Heart rate, it's healthy to have a low resting heart rate, but your social jet lag causes you to have unhealthy higher heart rates. All right. Here is a study in America. People in the east of a time zone, remember time zone defines chronotype, people in the east of a time zone are healthier. This is a report for cancer incidence. There's many, many cancers. Some of them are not significant if they cross this vertical line, but many are significant. And overall, here you see the top row, there is a 5 to 10% higher cancer incidence if you compare west to east. So it's unhealthy to live in the west of a time zone. Life expectancy. Cancer incidence here is another representation by Boryzenkov. Life expectancy in the European part of Russian Federation, it drops if you go west. In China, there's 4 time zones in China. Magnificent, well, a terrible drop if you go to the west. And cancer incidence is one of the possible reasons. Okay. So if you are live west in the time zone, it's an unhealthy situation. Now let's talk about daylight savings time. Of course, if you install daylight savings time, if you're already west in your time zone, if you install daylight savings time, you take the time of a time zone east of you. If you are half an hour west of your time zone, then you'll become 1.5 hours if you install daylight savings time. The situation will be worse, your social jet lag will be worse. And it's really a problem of what you could call the Western countries or industrialized Western countries, but I rather refer to it as Europe, Canada, USA mainly. Because these blue countries are the ones that have installed daylight savings time in the Northern Hemisphere and the orange ones in the Southern Hemisphere. So part of Australia, New Zealand and Chile. So it's really a limited problem to 30%, 34% of the countries in the world. Now, the history of daylight savings time is interesting. It was implemented first here in Canada, Thunder Bay, but for countries it was implemented around the First World War. The Allied countries, so Germany started to, I will go quickly, Germany started to install an energy saving procedure. Daylight savings time as energy saving, and quickly all the Allied countries followed. So it is also a war situation. USSR here, I want to point out, installed permanent daylight savings time in this period, but later in 2011 to 2014, and we'll have a look at that. Now, many people think that Benjamin Franklin installed daylight savings time, but he didn't. He just wrote an interesting, it was really a satirical letter when he was in Paris, because he was amazed that the Parisian didn't wake up before 12 o'clock noon. And so he suggested that every morning, as soon as the sun shall rise, church bells, and if necessary, cannons shall inform the citizenry of Paris to the advent of light. And that would save an enormous amount of candles. But he didn't refer to daylight savings time. The real person who did was this biologist, entomologist, George Vernon Hudson. And he published a paper, he presented it. He worked actually as a post office clerk, and he did shift work in his task. So he must have imagined we can manipulate working hours. And if we do so, we can actually have, so we can have more daylight hours to collect, in his view, insects. That was one of his arguments, of course. And as a result, in 1926, New Zealand installed daylight savings time. In Europe, the situation is such, I explained this already, we are now proposing in Europe something that we tend to call natural time. It's, again, pushing our countries in the England, the UK time zone, and we think that will increase health benefit because there'll be a minimal time conflict compared to the situation that we would have on the left if you would have permanent daylight savings time. Now the situation, I tried to figure out the situation in Canada. It's terrible. You can make a picture of this. This is what I got out of it, dive into it, but there are many regions that do different things, and I can only imagine, well, I could look at this and say, well, apparently it's possible, but maybe there are some costs to this, I don't know. But it could be better structured, I think. Social jet lag increases during your daylight savings time. It gets a big hit in spring when you install daylight savings time, and social jet lag is sort of, it never really, it comes close again, but it stays higher than it should, creating an unhealthy situation. Now here is a study in Russia when they installed, European part of Russia, when they installed permanent daylight savings time in 2011, and they quickly abandoned it 3 years later because they noticed that there was a high incidence among the youth, especially these 20-year-old kids. They had lower school performance and they had high incidence of depression. And it relates again with social jet lag that increased in that situation. So a conflict between your biological clock and your and the social time clock. Here is another study in the United States. I go quickly, but the take-home message is almost 22% increase of car accidents the further you are away from solar noon in those regions. Here you see again this bias towards the west. So it's also not good for traffic, and mainly because the school kids go to school and you get accidents with that traffic. Okay, here's an overview. I talked you through most of these numbers already, so I think there is a strong negative effect of daylight savings time. And I'll skip this. So this is the last slide. Where are we now? I think it's important that in 2019, just before COVID, we made a very important step that all major sleep and chronobiological societies signed a position statement against DST. Here are the societies that you may recognize. This is worldwide. There's a general call in the world to abandon time changes, all right? So we want to get rid of the switches as well here in Canada, I've heard. Political discussions for permanent daylight savings time or permanent standard time are going on. And that's very important. Getting rid of the time changes is not the end of the discussion. You should decide whether you want to install permanent daylight savings time or permanent standard time. And if you listen to my talk, there's a lot of arguments to install permanent standard time, right? And in Europe, we have a strong lobby group, I think. We're getting more and more active, and you can see here, these are the addresses, the internet addresses to find our argumentation and the packages. Having said that, I forgot to put in here that the SRBR website also has a very nice information package for people interested in this. And so here I am talking to Sean Kelly, an MP that's interested in this problem, and this is what you need. You need your politicians, and you need to convince them. Thank you very much.
Thanks so much. We open the floor for questions. Maybe, so I invite everyone from the audience to come to the microphone, but in the meantime, we have a question from someone online. That's the million-dollar question. Although there are many scientific arguments for abolishing daylight savings time and introducing standard time, these arguments do not seem to resonate with the general public. How can we change this and create a better understanding of the scientific results?
Okay, so it, where are we? Here, yeah. So it depends on how you ask. So first of all, it depends on how you ask the general public. In the Netherlands, there was a survey, as in Germany actually, well, in Europe, I should say, and their survey was asking, do you like summertime better than wintertime? So we laugh about this, rightfully so, because of course everybody likes the summer more. But the politicians, I had to face this argument when talking to members of parliament at the European Parliament. So if it's a statement that should be scrutinized. Is the public really voting for daylight savings time? And if you look in the countries where they have installed it, United States, Russia, I think Chile is one of them, Turkey, I believe, there are more examples. They all abandoned it after a couple of years because the public hated it. And the reason is that people don't realize that half of their day in wintertime, depending on what latitude you are, will be happening in darkness in the morning. All right? So I want to challenge that statement that the public thinks differently. I think they would agree with me as soon as winter comes. I can say more about it if there is no other questions. Yeah, please.
So can you comment on your slide where we saw the extent of social jet lag along the year? Didn't it look like that social jet lag, even if it was higher above this dashed line, it was less in summer? So in total. So does it mean we are earlier in summer and maybe sleep less in summer, and isn't daylight saving time just kind of kind of accommodating this earliness? So yeah. Would you say if we, that's like the season. So are we seasonal people? Right. Are humans seasonal in what? Maybe you can elaborate on that.
Yeah. I understand your question. So first of all, are humans seasonal? If we measure melatonin patterns, which we did in different times of year, Marijke Gordijn, my colleague, did that. we see only half an hour change between summer and winter, okay? But so the circadian clock, probably because of all the artificial light, isn't changing much over the seasons. So that's one thing. So we are seasonal, but because of artificial light, we're permanent summer days, almost, permanent long days. Now, there is a tendency of showing less sleep in diurnal mammals in summer days. This is probably because of all the sunlight that wakes you up in the morning or keeps you awake in the evening. Whether that is a healthy or an unhealthy situation, I don't exactly know, because I'm not sure whether we can manage with shorter sleep. But if you ask me, if you want to install daylight savings time, when would you do it? I prefer the summer. Yes, I think the biological effects are less strong in summer than they would be in winter. But if you ask me whether you would prefer permanent daylight savings time, then no, that's the worst situation. Permanent daylight savings time is terrible. Daylight savings time in summer is better. Abandoning it is even better. Okay.
Hi, thank you. I have two questions. One is to understand here that if we stop changing the light and we go to standard time, that means in June we'll have May, June, July, the sun will goes down at 8 p.m. and rise around 3 in the middle of the night. So we'll sleep half of the night with light, with sun, because it's not always dark like the last 10 days. So that's one of my, when I think about it, I say, I know it's hard to sleep with the night. I spent years in Scotland and it was dark from 11 to 3. So it's very difficult. So I was wondering, I mean, do we take that into account? That's my first question. The second question, we talk about the percentage of depression if we use you talk about depression, but what about bipolarity and manic episode, which are known to be triggered by light? So, and we know in the clinic, we have more cases in spring and summer. So what will be the effect for these people?
Oh, I don't think I'm knowledgeable enough to answer the last question, to be honest. But if I start with that, I think if that's triggered by light, bipolarity is triggered by light, you say?
It's inference, yeah. It's not the only reason, but yes, there is an inference.
Yeah. So sunlight must be devastating for those people. Okay. Well, I think it is relatively easy to avoid light, also sunlight. And it's also relatively easy to avoid light in your bedroom, all right? You can have better curtains, for instance, if it's a problem. But the point is, if you install daylight savings time, you're not gonna create more light. The amount of sunlight will be the same. It's just that you will create an evening that is very light. So that will, on the daylight savings time, will inhibit sleep onset. Agree? Yeah?
Not sure I agree, but I listen.
Oh, okay. Well, you just said yourself, you don't sleep very well in bright situations. So those people that want to sleep early, that would like to go to bed early when sunlight is still out there, they will have a sleep problem in the evening. So your argument that the sleep problem occurs in the morning, for other people that are more early, the sleep problems would occur in the evening. Now, there's another argument here, because people love to, and they enjoy the long evenings if you go biking or whatever. But that evening light that people, the outdoor sports are often an argument in favor of daylight savings time. Now, those outdoor sports will expose people to light specifically in the evening. That light will slow down the circadian clock. Hence, we will create more late types and we will create more social jet lag. Whereas if you have standard time, there's more light in the morning. You can go out for a morning run. Actually, I saw a lot of people running this morning here in the city. So Canadians do it. And that morning light will speed up your clock. So it will create more early types and it will reduce social jet lag. So my argument would be, Outdoor sports, of course, fantastic, but just replace those outdoor sports in the evening with outdoor sports in the morning, and it'll be a healthier population, I think.
Thank you.
We have perhaps more comments than questions from online as well. So there's our colleague, our American colleagues who are connected, and JP from Safe Standard Time is saying that they're also working very hard on this from a policy advocacy and public education perspective. So I think this is really nice to see this coming up from across the world. Roger Godbout is also saying east-west issues are important, but within the same time zones, distance from the equator is also very important in terms of impact. Think of Miami versus Groninger. So I don't know if you wanted to comment on that aspect as well.
No, I totally agree. I mean, these impacts are generalizations, as for instance, the question in the last questioner. You come up with times that are sometimes that are, of course, local relevant, but they vary if you vary latitude. So yes, that's very important. But you know, you have to simplify at some point to convince politicians. So we have to be able, as scientists, this is an important message actually. If you talk to politicians or to lobby groups, you have to be able to set your detailed scientific knowledge aside and come up with sort of the grand average story. I think that is important. That ability is crucial in these discussions, I think.
I'd actually like to make a comment on the comment. If you actually look at Miami and you look at further north, going further north from the equator, it's actually, it's not true that there's not a problem in Miami. So for example, if we choose permanent daylight saving time in Miami, we're going to have close to 100 more days per year where sunrise won't occur until the commute. And when kids are commuting to school and the mass commute on the highways is happening. That's happening at Miami, right? We're not talking about happening in Groningen or Seattle, things like that, all right? And so similar things are happening further north. And so it's really not that big of a difference when we're talking about this daylight saving time change for that morning commute especially, which is a risky time.
Hi. I was wondering, speaking of latitudes, has anybody studied the effect of long days in northern latitudes on health, or is that too complicated because the winters are very short?
What did you add in the last sentence?
Oh, okay. So you were saying you didn't know how healthy it was for people to have extended light, was one of the comments. And I was wondering, are there any studies of northern populations that reveal effects of these short, then long, then short, then long seasons?
Yeah. I'm not completely knowledgeable about that question. We do tend to believe that incidence of depression increases towards the north. Maybe there's psychiatrists, psychologists who have more detailed knowledge about that than I do. I do know that if you go above the Arctic Circle, there are some people that, like the Sami in northern Norway or so, they seem to be completely free running also in winter nights, herding the reindeer. They seem to be absolutely happy in those conditions. But that's just free running circadian clock. It is very abnormal situation, if you compare it to the other cities where they do install social time and they do have work days that are having a 24-hour rhythm, and but they really are good at blocking out the light as best as they can, and in wintertime they are using artificial light. So their situation becomes more and more similar to ours, I think, at our latitudes. But I don't know, there is a higher incidence of depression, but at least for Europe I can say part of that can also be explained by genetic variation. So and part of it can be explained by alcohol abuse, which can be a result of it or a cause, and so you're running in very difficult analyses. I don't know what the current status of knowledge is there.
Okay, thanks.
What can you do if you have social jet lag? Like,
What can you do if if you're facing social jet lag?
isn't that what you described? Like people,
Right.
they have delay during the weekend.
Right, exactly. So I talk about this with my students, and they like the topic a lot because they almost all are facing social jet lag, especially the male students. And the first of my message is, don't let anybody tell you that you're a lazy student, because it may be your internal biological clock. Now, what can you do about it? I'm saying sunlight is a medicine. Sunlight is a medicine, and morning sunlight will speed up your clock and will make you an earlier type and will therefore reduce your social jet lag. And so if I talk about changing school times, it always goes hand in hand with the advice to do morning sports, for instance, or let the students go on their bikes to school in the morning. Yeah. Which is easy to say in the Dutch population, I realize that. Yeah.
On this, thank you so much, Professor Hunt. This was amazing. And thanks for the audience for your participation. So this closes our public lecture, and I'll invite people on site to stay for the next session in 20 minutes. So we have a health break, 15. 10.
Thank you for your time.